right, let's go ahead and take a look at Unit 5, Day 2. We are talking about coordinate geometry, and again, we are focusing on quadrilaterals. Those are four-sided polygons. Okay, then you'll remember from our Day 1 lesson in class that we talked about parallelograms, rectangles, rhombi, that's the plural of the word rhombus, and squares. Okay, so we're going to look at that in the coordinate plane. Coordinate geometry, we're going to deal with classifying quadrilaterals as parallelograms, rectangles, rhombi, or squares, and we're going to use the following steps to be able to do that in the coordinate plane, using coordinates, x, y coordinates. We're going to check the congruency of sides first, and then also check the congruency of diagonals. Okay, remember, diagonals are those segments that connect the opposite vertices of quadrilaterals. Okay? All right, so there's four cases we're going to look at. Now, again, if you need to pause the video to copy any of this down, go ahead and do so. Should have started with that, but make sure you have this copied down correctly in your own notebook paper. And we're going to take a look at some information before we begin our examples. All right, we need to take a look at these cases. There are four cases, so I want you to make sure you draw this rectangle, this grid, in your notes, giving yourself 2 lines for each of the cases, so you can kind of get the idea of how that should be shaped. And there should be 3 columns, so we got 4 rows, 3 columns. All right. Make sure this middle column, you leave yourself enough room. You can kind of see I go from just inside the margin all the way to the opposite margin. All right. So pause the video to give yourself time to do that. And we should be ready to move forward. All right, the first case is if we end up having a parallelogram. Okay, that is parallelogram. Kind of pretty small there. All right, in a parallelogram, you need to remember that opposite sides are congruent, and diagonals are not congruent. Okay? If you check the sides and diagonals, you'll notice that opposite sides are congruent and diagonals are not. That makes it a parallelogram. So it would be a situation like this. We get different lengths for the diagonals, but the opposite sides are congruent. Then we can know that it's a parallelogram. Okay, but if we check our sides and diagonals and we get that opposite sides are congruent and diagonals are congruent, okay, if that's the case, that opposite sides are congruent and diagonals are congruent, then we know our quadrilateral is a rectangle. Okay. The third case is that if we find out that all 4 sides are congruent and the diagonals are not congruent, that makes it a rhombus. And the fourth case, if we get all four sides are congruent, and the diagonals are congruent, then it is a square. And so those are the cases we're going to look at, and we can look at sides and diagonals and determine that. And to determine whether sides are congruent or not, or diagonals congruent, all of this is going to be using the distance formula. Okay? You remember the distance formula is this. All right? So we're going to use that when we check congruence of sides. But we can also use slope of certain parts of these quadrilaterals to figure out some other things. So here's our first example. Okay, so go ahead and take a moment to pause the video and copy down what you're given in example 1. And we're going to be able to use slope in the coordinate plane also because, if you'll remember, in the coordinate plane, parallel lines have the same slope. We'll have equal slopes. Okay, so pause if you need more time to copy this down. Make sure you include the drawing. But let's say we are given parallelogram ABCD. And if we know that A is located at -2, 2, and D is located at -5, -2, what is the slope of BC? Well, you'll notice that I give you the coordinates of A and D, but I ask about the slope of BC. Remember, this is a parallelogram. In a parallelogram, opposite sides are parallel. That means they'll have the same slope. So in order to find the slope of BC, all I need to do is use the coordinates to find the slope of AD. So we're going to find the slope of segment AD by doing the slope formula. And I want to remind you what the slope formula is. We're going to take y2 minus y1 over x2 minus x1. So again, make sure you have this copied down. This is your slope formula. It's very important. And so from here, I just start plugging in the coordinates. Now, it doesn't really matter which one you call x1, y1 and x1, y2, or sorry, x2, y2, as long as you get the order to match. So let's say we take the difference of our y coordinates. We're going to do 2 minus -2 for the top. And then the difference of the x coordinates would be -2 minus -5. So these minus negatives both change to addition. Two plus 2 is 4. -2 plus 5 is 3. So the slope of line AD, or side AD, is up 4 over 3, or 4/3. That means the slope of BC is also 4/3. And so you want to remember things like that. In parallelograms, opposite sides are parallel, so we'd be looking at same slopes for opposite sides. In rectangles, okay, opposite sides are parallel, so we'd be looking at same slopes, but also there are 4 right angles. So every pair of consecutive sides should be perpendicular. Remember that perpendicular lines have opposite reciprocal slopes. And in a rhombus, remember that the diagonals are perpendicular, and so we should have right angles with the diagonals. So the diagonals should be perpendicular or have opposite reciprocal slopes as well. Then if we can show that it is both a rectangle and a rhombus, we can show that it is a square. All right, let's try another example. In our next example, I want you to give the most specific classification for each quadrilateral if we are given the vertices that each one shows. And that can be a rectangle, rhombus, square, or parallelogram. Okay, so if I give you these vertices, these represent some quadrilateral, which is either a rectangle, rhombus, square, or parallelogram. We are going to use our cases from the other page to determine whether or not it is any one of these, or maybe none of them. Maybe it's just a quadrilateral. Okay? So we are going to first check the congruency of sides. So we're going to find the lengths of all 4 sides. So we're going to check xy, yz, zw, and xw. Now we know that sides should follow this order. We're going to assume that this would be x, y, z, then w in that order. Okay, and so we can make that assumption. All right, so we know that these are actually the 4 sides and not diagonals. Okay, so we're going to use our distance formula to find all 4 of those lengths. xy means we would take the difference of the x's, 9 minus 8 squared, and then the difference of the y's, -4 minus -2 becomes -4 plus 2. 9 minus 8 is 1. 1 squared is 1. -4 plus 2 is -2. -2 squared is 4. And 1 plus 4 is 5. So the length of side xy is √5. Okay, and we're going to try the length of the rest of these. I want you to pause the video and work these out yourself until you get the other 3 side lengths in radical form. It doesn't have to be simplest radical form, just radical form. But pause the video to give yourself time to do that. All right, this is what we should get. We get that yz is √45, zw is also √5, and xw is also √45. Now you'll notice, by drawing the picture, and it doesn't have to be to scale, these points would not plot out this way necessarily in the coordinate plane, but you'll notice xy is √5, and zw is √5. And then yz is √45, and xw is also √45. So we get opposite sides being the same. So that means, I'm going to flip the page back for a second. Since we have opposite sides that are congruent, it can be a parallelogram and also a rectangle. Okay? All 4 sides were not the same, so I know it's not a rhombus, which means it's not a square. Okay, so I'm going to go back to the 2 cases where opposite sides are congruent. We know it's a parallelogram, but it could also be a rectangle. We want the most specific classification. So now we need to determine between these 2 which it should be. And that means we need to look at the diagonals. If the diagonals are congruent, then it's a rectangle. If they are not congruent, it is just a parallelogram. So we're going to look at the diagonals. Now, drawing it out helps you understand which segments are the diagonals. xz is one diagonal, and yw is the other. So I want the distance formula for those. Okay, you're going to use these coordinates, x and z together, and y and w together. I want you to pause the video to give yourself time to do that. And we do get that both are square root of 50, which means the diagonals are congruent, which makes this a rectangle.